Welcome to a new guide on this channel, and on this occasion is the Behringer EDGE. This is not a review, it's a complete deep dive guide about this synth. Everything on this guide is in chapters, so if you look at the description or the timeline, you can jump to a section or skip the ones you don't want. If you like this, please like and subscribe, and if you have the money and you want to buy me a coffee, you can. Everything is in the description. The EDGE is not a traditional drum machine. Yes, you can create percussive sounds, but I'm pretty sure that you will end up using it in a different way. Now, first we need to learn all the controls without using the patch bay, and then we will go through all the ins and the outs one by one. Okay, so it makes sense that we start with the VCOs with this section right here at the top. You have two different VCOs and you can run and stop. You can start the sequence by doing play and stop, just like that. Now with each of the VCOs, you can control the volume of the VCOs. If I go down in the number 2, we are now hearing the number 1 alone. So right and left, you have the frequency of the oscillator. You can go down or you can go up. And notice that the transition, it's free, it's in hertz. So it's not in semitones or stepped. Now the other thing that you can do is you can choose between a square or you can do a triangle, which is much softer. I can go down in volume on the VCO number 1 and still go up on the noise and get a little bit, just a nice blend between the oscillator number 1 and the number 2. Now the noise generator can do white noise as we are doing right now, or we can do pink noise. So that's the first thing. You have the level, you have the frequency, you can select the waveform, and then the noise. Now, then you have the first kind of modulation in the synthesizer, which is going to be pitch modulation. I'm going to go up on the oscillator number 1 and leave the number 2 untouched, and I'm going to be playing it. Now, the first kind of modulation is going to be pitch modulation, and these are the controls. You have the envelope right here and the decay right here, and everything is at noon. So this, what it does again, is going to pitch up, or it's going to pitch down the oscillator. If I go up in this control, it's going to start at a certain frequency and then pitch the oscillator. And we can see it right there. If I go slower, we can see in the spectrum how it goes, and it moves like this. If I go to the other way, it's going to do the same thing, but the opposite direction. This is what this does. It's going to modulate the pitch. That's the first kind of modulation on the synthesizer. Also, you need to decide how you want to modulate it. And right here, you have the decay of the envelope generator, which is this one. So if I go down, the modulation is super short. And I'm going to go up in pitch. But this is super short. If I go the other way, we can really kind of see it and hear it. Now, both oscillators can do the same. If I go up in the volume of the number 2, we are going to be getting that modulation. So maybe on this I can go up, and this one I can go the other way and make it a little bit shorter, and even change the frequency of the number 2 if I want to. And maybe a little bit of noise. And just like that, you have two oscillators doing two different things. I'm going to go back to default, so no modulation. If I play it back, we get something like that, and it's fine. And I'm going to be using just the oscillator number 1. This is just easier to hear. Now notice that right here in this section, we covered pretty much everything. The only thing we didn't discuss is going to be the sequence and then the other type of modulation that you have right here. So first is going to be the SEC or sequence pitch mod. And it says oscillator 1 and 2, it says off, and then it says oscillator 2. Now, this section is talking about the knobs that you have right here at the bottom, especially the pitch section, all of these knobs. Now, if I play it back and we stand right there in the middle where it says off, it means that whatever I do right here with these controls, nothing will affect whatever it is that we are doing because we are staying on off. Now, what you can do, you can choose to go to 1 and 2, and this, what it does, is going to modulate the pitch of the oscillator 1 and the 2. And if I go up on the number 2, we can hear that one is being affected by whatever we do on these controls. Now, notice that these controls are super sensitive, so you need to just adjust it a tiny little bit. If you do too much, it's going to be too much. Now, I'm going to go faster. So now both are going at the same rate, and both are being modulated by these controls. That's the first option. Remember, the one in the middle is going to be off, so these ones are doing nothing. But if I go to the number 2, the number 1, the pitch stays untouched, but now it's modulating just the number 2. and you get, very interesting sounds. So I'm going to stay on off. I don't want any modulation. So now we know that with these knobs, these controls, we can modulate the pitch. What about the velocity? So the velocity is going to go up and down in volume pretty much. If I go up on this one, we are going to be getting a rise in volume on this one. If I go down, it's going to go down in volume almost to full silence, almost. And just like this, you can create a nice sequence. And if we enable again, maybe the pitch, you create a super cool type of sequence. Notice that right here, we get no sound, pretty much. Alright, so in conclusion, you have the two oscillators. You can do square and triangle. You control the pitch of this. You can modulate the pitch with the envelope and control the decay. And at the same time, you can use the sequence to modulate the pitch or to go, to change the pitch of maybe 1 and 2, or maybe just the 2, and then go up and down in volume with the velocity controls. So this is the most basic thing that you can do with this synthesizer. With every synthesizer, you have a way of just taking traditional oscillator waveforms and do something else. On this one, we have hard sync, and then we have FM. Now, when the sync is off and we play both oscillators at the same time, nothing's happening. Now, if I turn it off, it's going to sound very different. So this, what it does, is going to make the oscillator 2 sync to the number 1. So now 1 is the master and number 2 is going to be the slave. So now if I change the oscillator number 1, it will affect the number 2 because it's the slave. This is how syncing works. So if maybe I stay right here and go up with the frequency of the number 2, can hear the change. But also if I go down to the number 1 or change something about the number 1, it's going to give you this sync sound. Now remember that still using the envelope will affect whatever use that you do. Alright, so this is how the sync works, and I'm gonna just turn it off right now, just maybe stand right there. Now the other type of modulation is going to be the FM amount, and notice it says 1-2. So this means that the oscillator number 1 is going to be frequency modulating the oscillator number 2. So if I play it again, and I go all the way down on the oscillator number 1, so we are not getting it. We are just getting the oscillator number 2. We are doing none of the FM amount. Still, if I go up, we can hear a change on the oscillator number 2. Notice, remember, we are not listening to the number 1. It's just the number 2. And if I start changing the number 1, it will affect the number 2 because we are doing frequency modulation. This one is affecting the 2, right? That's how it works. Now you can decide how much of this you want to do. If you go down, it's going to be doing less until you do nothing. Now you can still go up on the oscillator number 1 and just get it, but the number 1 stays unaffected. If I go down, we just get, the square. There you go. So this is how it works in terms of modulation, at least with the oscillators. You have your envelope to modulate the pitch, then you have your hard sync, and then you have your FM. Right, so now it's time to talk about the filter. So let's just, get the obvious part of the way. It's a very simple filter. If I play it and I'm using just the oscillator number 1, I'm going to go a little bit slower. We're just using the oscillator number 1. You can choose between a low pass and a high pass. It means if I go to the cutoff and I start moving it when we're standing on LP, we are chopping the higher frequencies. We can see it right there in the spectrum. Right, if you go all the way down, you're just cutting pretty much everything. On top of this, we have the resonance. This is a bump of the breakpoint of the cutoff. So we're going to be getting that resonant peak. Alright, so for now I'm going to go down, maybe just stay around here with the resonance. Now, the other thing is going to be a high pass. If I go to high pass, we are doing the opposite. Instead of chopping highs, we chop lows. And it is that right now, if we see the spectrum, the lows are just lower. If I go the other way, we're going to see and hear the change. Now we are doing pretty much nothing. So as I keep going up, right here, we get less lows and more highs. Completely different to the high pass. So then you have the other section of the cutoff of the filter section. You can modulate it by an envelope, and then you can decide how much of the envelope will affect the cutoff or will modulate the cutoff, and then how the decay is of the envelope. So if we play it back, what we want to do, we want to maybe cut some frequencies. But at the same time, every time that we go through a step, I want to modulate this cutoff. Well, this is going to be the envelope. If I go to the plus side, it's going to modulate the cutoff up and down, just following whatever it is that we are doing right here in the sequence. If I go all the way down, up is going to be more aggressive. Now you can do the same and do the opposite, which is going to negatives. It's going to invert the instruction. And that's why it says minus, and that's why it says plus. Now the other thing that we can do, and I'm going to go right here, maybe just chop a little bit of frequencies. I'm going to go all the way up in the envelope. You can decide the decay. If I go all the way up, what is that? We get pretty much nothing. And it's because the times are just, super long. I can go shorter, and you're gonna get the plucky or pluck type of sound because it's super short. This is completely up to you and depends on what you want to do. Alright, so what else do we have on the filter? So we have the decay, the envelope, we know this, the resonance, the cutoff, but you also have a noise and then it says VCF Mod. By default, this is noise. And I'm going to be removing the envelope and going up maybe right here to the cutoff. There we go. And I'm going to go up on this one. So what can we hear? So it's noise, right? So we get a pretty noisy type of sound. So this is what it does. It uses the noise generator that we have right here to modulate the cutoff. That's why we get this noisy sound. It's modulating the cutoff super fast. This is what the noise means. But then it says VCF Mod. And it's because with using the patch bay, we can disconnect or remove the noise as a modulator to the cutoff and use maybe something else. And that's going to be the VCF Mod side. But by default, this is hardwired to use noise as a modulation source. Now, still, when you modulate with noise, you can modulate with envelope if you desire. Alright, so much later, we're going to talk about the patch, the ins and outs, and we can disconnect the noise, and we can modulate the cutoff with maybe some other source. Alright, so then you have the output section, the VCA section. And if I play it back, this is just pretty simple. This is going to be the volume. If I go up, it's going to go up in volume. If I go down, it's going to go down in volume. Now, the interesting part of the output VCA section is the VCA mode, and then the decay. If I play it back again, I'm going to stand around 50% on the volume. Now, the decay is going to control how short the VCA, the envelope of the amp is. If I go up, notice that there's almost no separation on each of the steps. It's because it's super long. If I go down, it's going to get shorter. And this controls again how the volume goes out. It's not the VCF, but they're very similar. If we go down on this one, we use the cutoff is going to make a plucky sound. Well, this is pretty much the same, but it's talking about volume and not filtering. Right. This is again pretty obvious. We go down, it's super short. We go up, it's super long. Now then we have something very interesting, which is going to be the VCA mode. Now, right now it says fast. It is what we are getting right now by default. Let me stop it. So fast is going to be a sharp, fast attack. Starts right away. That's why if I go down, we can hear a very plucky sound, super fast. Now, if I change it to slow and I play it back, we can hear that the sound almost like the attack time is super slow. So it's kind of a show going up and down every time. And if I go slower, you can really see it in the spectrum. Notice that now the sound goes smoothly up or ramps up and then ramps down every time that we go to a step. So fast is super fast up and then it's going to decay. Well, in this case, again, it's going to be a slow attack and whatever decay we choose right here. And if not, it's going to be a fast attack and whatever decay we decide on the output section. Alright, so maybe you didn't notice, but we just covered the whole panel. Pretty much all the options and what you can do by default without using the ins and the outs. The last thing we need to discuss is going to be the sequencer. And it's pretty straightforward. If I play something, it's going to go, you can decide the tempo, and it's going to go through all the different steps that you have available. Now still, what you can do, since this is very sensitive, and if I maybe change to 1 and 2, and I can do maybe something like this, right? We are messing with this. So since everything's super sensitive, it's really hard just to listen or to fine-tune whatever it is that we do. So what you get the trigger and you get the advanced. You have 8 steps. The advanced will make it advance through all the different steps. And maybe if you want to audition whatever it is that you're doing in step number 4, then you have the trigger. This is going to play or let you hear whatever it is that you're doing right here, especially when we go right here. And then if you are maybe using a tuner or you want to fine-tune what you're doing on step 4, for example, you can do so. That's why you have the trigger. And then you just keep maybe advancing on all the different steps. Just, make the changes that you want to make. This is why you get the trigger, play, and advanced. And whenever you're ready, you just play it back and you listen to the whole sequence. Another interesting thing that you get is going to be the clock. So right now it's standing on internal and external. So it's whatever we use on the patching on ins and outs or internal of the synthesizer. This is why this decides the speed of whatever it is that we are doing. Now then you have the other side, which is going to be what is that you're using as the main clock. In this case, I don't have the USB connected, but if you want to select USB, you can do so. Or if you want to use MIDI as a clock source, you can do so. Now the interesting part on this synthesizer is that when you are syncing through USB or syncing through clock, you can scale whatever instruction that you get from the external source. Now right now, if I play it, nothing happens because it's expecting an instruction, outside instruction, maybe USB or MIDI, just to, make it work, make the sequence work. And since I have nothing connected, it's just not going to work. But if I had something, this one is going to scale it up or scale it down. And it's super interesting that we get this option with the synthesizer. Okay, so this is what you can do with the main panel without touching the ins and outs. This is a highly creative device, but it all depends on how much time you spend fooling around with controls, not twisting knobs, not experimenting, and not using effects like pedals will just not work here. Alright, since now you know how to control the main panel and you know everything about it, we can start with the ins and the outs. Alright, we are going to go one by one of all the ins and the outs, and I'll be providing an example so I can make sure that you get every in and every out. So the ins are going to be white and the outs are going to be black. You cannot connect an out to an out or an in to an in. You can only go from an out to an in. Now all the outs will output some kind of message in voltage. Everything is voltage right here. Some of them might output from -5 to +5 volts, or simply just output from 0 to +5 volts. So this out, the one that says pitch, is going to be the pitch section of the sequencer, the knobs that we have right here at the bottom. So if I connect maybe a cable right here, whatever is going through this cable at the other end is going to be outputting, or whatever we connected is going to receive an output or a voltage. Now the case of the pitch is going to be from -5 to +5 volts. Now, if you have a multimeter, you can check whatever it is that you're doing on the other end. You need to connect the tip to the red and the black to the sleeve, which is, round. So when you go right here, notice that, again, we are going from the pitch out, which is whatever it is that we have right here. And I'm going to be maybe standing on the step number 1. So now this knob is going to output some kind of voltage. If I go up and then just keep moving up, notice that the values are going to be changing. If I go up, it's going to go up to 5 volts. And if I go down, it's outputting less and less, and then until we go to -5. So this instruction, this voltage that we are providing on each of these pitch knobs is going to go out right here, and we can connect it maybe in a different place, and that instruction will make a modulation happen. Okay, so now we know that this pitch is outputting from -5 to +5 to whatever we do on the pitch knobs. So where can we patch it in? Now we have the noise level. This is the first one. I'm going to go to the noise level, and this one controls is the in for the level of the noise. If I play it back, we are going to be getting something, but notice that we cannot even hear it. So I'm going to go all the way down to the oscillators. Everything goes silent. I just want to get the noise. Now the knobs right here are maybe at 50% or even less. It means that it's outputting 0 or maybe less. And noise is just level. So it listens from 0 and then it goes up to 5. If it's less than 0, it's complete silence. Now if you keep going up, right here is going to be outputting positive voltage. And the level of the noise is just it will increase. And just like this, you can create rhythmic patterns with noise. And if you so desire, you can maybe use the oscillators and blend it with the oscillators. And remember that this controls, they will control the pitch. So by connecting a cable right there to the pitch out, it's still, not disconnecting the pitch. So if I maybe go up, we can hear pitch, and we are going up and down in volumes, in the volume of the noise, controlled by these knobs that we have right here. And just like I said before, if we go, maybe I'm going to turn off the pitch. If you go below 50%, you're going to be, or 0%, you're going to be going to full silence or do nothing with the noise. So at some points, we are going to be getting silences if you're just using noise. Let me just do it more obvious. All the section is complete silence. Okay, so coming up next, it's going to be the velocity out. We have the pitch out, which means that we take these knobs and we use it for something else, and then you have the velocity, which is going to be right here. If we talk about velocity, we are talking about the knobs that we have right here at the bottom. So it's the same example. The only difference is that the pitch knobs, they will output from -5 to +5, but the velocity knobs will output from 0 to +5. Now we can do the same example that we did before. Maybe take the velocity and go to noise. I'm going to connect the velocity right here. And then I'm going to be going to the noise level and see if we get something. I'm going to go there and just patch it in. And I'm going to be playing the sequence. But this time, I'm going to be going down in the level. Now right here, we are on 50%. Maybe I'm going to go all the way down and it's 0. So the noise, it's all the way silent. If I go up, it's going to be louder and so on and so on and so on. Just like we did before, let me just move the cable, just like we did before with the pitch controls, pitch knobs. Alright, the only thing that you need to remember again is that this is -5 to +5, and this is from 0 to +5 volts. Alright, so since now we understand some of the ins and the outs, everything is just going to get a little bit easier. Hardwired, we know we have the noise and the VCF mod. And if I play it back, we know that this one, if we go up, is going to modulate the cutoff with the noise that we have right here. But this also says VCF mod. So it means that we can disable the noise and use something else. So if I go right here, you can find the VCF mod. It's going to be this one. Now, if I play it back, we can clearly hear that the noise is modulating the cutoff. Now, as soon as I plug something in, we don't get it anymore. And I'm not using it anywhere. I'm not connecting it anywhere. So when you connect an in, it's going to disable the noise, just going to remove it out of the equation, and it will use something else on the other end to do the cutoff modulation. And the only thing right now that we know is the velocity and the pitch. So we can use maybe the pitch, which are these knobs, to do a controlled or on-demand modulation. I'm going to be connecting this, and let's we get something. Remember, this is -5 to +5. Now, I'm going to be maybe going all the way down. I'm going to go down on the cutoff, and I'm going to be moving these knobs. Do we get something? Something new? No, we don't. It is because this also works as an attenuator. If we go all the way down this one, none of this, it's outputting anything. So we can, with this one, we can control how much we do of this modulation. And in this case, it's going to be like an intensity type of knob. If I will go up, we go full intensity. So whatever we do right here is going to be applied fully to the modulation of the cutoff. I can go down, it's going to move it down, or if I could go up, and so on and so on. We are just modulating the cutoff. I'm going to go back to defaults, and I'm going to go down on the noise and the VCF mod. So now you know that whatever you connect right here, you're going to be able to modulate the cutoff with maybe a different synthesizer or maybe a different out. Then we have the in of the 1 and 2 FM amount. And if you remember, is going to be this control. Now, this one we have the same idea, but the difference is that we are not disconnecting how much FM we do. And if we take the same, the same patching, the same plan, I'm going to take the pitch out and I'm going to be connecting it to the 1, 2 FM amount. And what we do, if I play it back, is that with these controls, we are going to be messing with whatever FM amount modulation we do. And I'm going to go up on both and try to align them. Now, if I go up on the amount of the FM, we are doing a tiny little bit. So now these controls are going to be messing with this instruction. If I go all the way down, we still get it. If I disconnect it, we get nothing. Now remember, when you are doing frequency modulation, it's a good idea to separate the oscillators to get a greater type of effect. Alright, so that's the main idea. And still, this control still works. You're not disconnecting this control. Okay, so if we keep moving forward, we have the VCA in, and as you might guess, this is the amp, is going to be the volume. Now, if I connect a cable to the VCA CV, I'm going to be connecting it right here. And if I leave it unplugged and I play the sequence, nothing happens, but it's just a little bit weird. If I just disconnect it again, it works correctly. If I connect it, a little bit weird. Now, I'm going to be touching this. Maybe I'm going to go down in volume. Notice it's just, sometimes if I touch it, it's going to be loud. Sometimes it's going to be softer. It's going to be soft. I'm going to disconnect it. So when I touch it with my finger, what I'm doing, I'm outputting or just sending a voltage to the VCA CV. And this will mess with the volume, and it will also mess with the EG. Now, if we need to create an example, what we can do, we can still use the pitch out because we are outputting some kind of a voltage, and we can go to the VCA CV, and this will just mess with the level and the amp. I'm going to connect it and move the cable, and now I'm going to be playing this sequence. Notice that there's just not a lot of difference. Now, remember that from here, we can go to -5 to +5. And if we are talking about volume, we cannot go -0 because it's just full silence. So if I use the pitch and I go down, everything is going to be silence. Right? So in this case, I'm going to be going up. And sometimes it's going to be softer, sometimes it's going to be louder. If we go to +5. Now also notice that this messes with pretty much everything, including the EG. And just to give you an example, I'm going to be stopping it on the step number 1. Notice I'm not playing anything. So when I stop right here and this voltage, it's outputting, I guess it's 2 point something, the volume stays right there at the top. It's not stopping. It's keeping the volume open. So if I move it down, it's going to go to full silence. But if I go up, it's going to go loud. So this is something that you need to be aware when you connect something to the VCA CV. You're messing with the volume of the synthesizer. And if I, play it back or maybe advance it, you're going to be getting different volumes. Now, if you want full silence, maybe outputting less than 0 is going to fix the issue. Still, if you don't want to use it, you can just disconnect it. Now, one tiny little thing that you need to know is that right now I'm trying to provide an example with the available ins and outs. I'm not going to be using a different synthesizer. Maybe just using a different synthesizer that outputs some kind of instruction. We just can connect it to the VCA CV or maybe some other instructions, and we can get a better, just a cooler type of modulation. Alright, so now it's time to talk about the trigger out that we have right here and the trigger in that we have right here. Just like I said before, the trigger out, for example, is something better used with an external synthesizer. When I go to the sequencer and I play it, every step is going to trigger the envelopes of the synthesizer. This is how we can go through all the steps. Same thing right here. This is the trigger button. Every time I tap it, I'm going to be playing whatever position. So we are triggering the envelopes. So this is what it does, is going to output a voltage, right, to the envelopes. And it's going to be from 0 to plus 5 volts. But it's a pulse. That's why it's called a trigger and not a gate. It's a very short type of instruction. So for example, if I try to use it on this synthesizer alone, I could use the trigger out to maybe go to the VCA CV in. And every time that we go right here, maybe to the trigger, we can hear a very pulsating sound. That is this super sharp. If I disconnect it, we are not getting it. So what we hear is that pulse. Right, again, so this is something maybe that it's better used with a different synthesizer. Now then we have the trigger in is going to be this one. So instead of outsourcing whatever trigger that we do right here, we can import a trigger to this synthesizer. So if I patch it in right here, and I maybe provide voltage, maybe with my finger, at some point is going to be triggering. Now, of course, it needs to be, the voltage, it needs to be at least from 0 to 5 volts. So maybe we can connect this to a different synthesizer, and the other synthesizer is going to be triggering this one. Now, still, we can maybe build an example with the oscillator number 1. I'm going to go to OSU1, and I'm going to be patching it right here. Now remember that right here we have the triangle and we have the pulse. I'm going to go all the way up on the oscillator number 2 and all the way down on the 1. And this one, since it's free, is in hertz, you can go down and use it as an LFO. So at some point it's going to go super slow and we are going to be getting that pulsating, or we're going to be triggering the envelopes with the oscillator. If I go all the way down, this is how fast it goes. Now it doesn't matter if I go up in tempo or I go down in tempo. The oscillator is the one triggering the synthesizer. Well, let me just disconnect it. So the trigger, this trigger in, is going to take from 0 to 5 volts. It could be a pulse or it could be a gate signal. Now right here we have the velocity in. If I play it back, we know that these knobs are going to go up and make it go up and down in volume. As soon as I connect it, I'm going to make sure that I keep the other end right here, and I'm going to be connecting something. As soon as I do so, the sequence is still going, but it's, we get nothing. We get no sound. And it's because when we connect something to the velocity in, it's going to sever or disconnect whatever these knobs do. And remember, they are in charge of controlling the amplitude. And I have to give you a warning right now because it's going to go super loud. Now this one is going to take an instruction. It's an in, right? It needs some voltage. If I provide voltage, it's going to be maybe super loud or it's going to be super soft. It depends on how much you provide to this in. Now this velocity in takes from 0 to plus 5 volts. Now what we can do, the main takeaway of all of this, is that maybe we can use a different instruction to control the velocity. And we already have, a lot of instructions. So you could use the pitch that we have right here and just connect it to that out. So it's going out from the pitch, this knobs that we have right here, going to the velocity. If I play it, we are going to be getting something. Or in this case, we get nothing. Remember that the pitch is from -5 to +5. So if everything is on 0, we are just outputting no voltage. I need to provide something for the velocity to work. And if you think about it, we are doing pretty much what we can do with these controls. Which maybe on this example, it makes no sense. Now, again, the main takeaway of this is that when we connect something to the velocity in, we are disconnecting the controls of the velocity. So maybe I could take a constant instruction, maybe like the trigger out, and have the trigger handle the velocity. It is going to be a constant velocity. If I play it, maybe go down in volume, everything is going to be constant, which is fine. The trigger is handling the velocity. Now, if I move these controls, nothing is going to happen because we are disconnecting them, right? So the main idea now is that this whole section, it's completely free. We disconnected everything. Disconnected the velocity knobs from the main amp. So now we can connect something else and use these knobs to maybe modulate the pitch or maybe modulate the VCF. And I'm going to be doing just that. Since now we have these knobs free, I can use them to do whatever I want. I'm going to be chopping some of the frequencies, and right here you have the velocity out, and this out is all of these knobs. So if I connect something right here, whatever we do with these knobs are going to be instructed right here. Maybe we can go to the VCF mod, the one that we have right here, and this one will modulate the VCF. I'm going to connect it, and I'm going to go right here. Now remember that the VCF mod is this one. If you're going all the way down on this one, we are doing no modulation. And the plan is to modulate the cutoff with whatever instruction we provide on the velocity knobs. So I'm going to be providing, or maybe I'm going to go full. And whatever it is that we do right here is going to modulate the cutoff. And again, we get a really cool sound. We are just sequencing the modulation of the VCF. Right. That's cool, right? Okay, so coming up next is going to be the oscillator 1 and the oscillator 2 out. So this one's what they will output is whatever is that we do on the oscillator 1 and the oscillator 2. And it's not just the waveform, it's everything that we do, envelope, frequency, the type of, shape, and everything else. And we can maybe connect it from the oscillator 1 out, and then whatever is that we do on the oscillator number 1 is going to be outputted here. So I can use it just like we did before, maybe as an LFO or instruction, or maybe we can go to a different synthesizer and do something else with this instruction. So I'm going to be doing the same thing that we did, VCF mod. I'm going to connect it right here. So now the oscillator number 1 is going to be in charge to modulate the VCF cutoff. Now if I play it, I'm going to be maybe going right here and just put everything at 50%, so we have no issues with the velocity, and I'm going to be going all the way down on the oscillator number 1 and all the way up on the oscillator number 2. Now, as soon as I play it, we are going to be getting, maybe I'm going to go down for now on this one, we're going to be getting something like this. This is the oscillator number 2, and I'm using the shape of a square. I'm going to go brighter, and now the plan is to use the oscillator number 1 as the modulation source. So since we are connecting to the VCF mod, we are going to be getting it. Now, whatever it is that we do on the oscillator number 1 is going to affect the modulation. So if I go down, we can use it as an oscillator. It's a common oscillator. And remember that you have a shape of a square, or maybe you can do a triangle. And whatever it is that we do, even with the envelopes, is going to modify the instruction. So again, we are just taking whatever the oscillator is doing and using it to do something else. That's the plan. And the same thing goes for the output of the oscillator number 2. Okay, so now it's time to talk about the oscillator 1 CV and the oscillator 2 CV in. So these inputs are about the frequency or the pitch of the oscillator, and what they take is 1 volt per octave. What do I mean with this? If I connect something right here to the 1 or the 2, what they need 1 volt in order to go 1 octave up or down. So if I provide maybe 1 volt, it's going to be 1 octave. If I provide 2 volts, it's going to be 2 octaves, then 3, and 5 volts, 5 octaves, and so on and on and on. And just like this, we could create an example just like we did before. I'm going to connect the trigger to trigger out to the in of the velocity, so we can disconnect whatever is that we do with the by default with the velocity knobs, and we have them free and we can use them someplace else. So I'm going to be taking the velocity out, and I'm going to be providing an instruction with these controls. And remember, they do the velocity knobs right here at the bottom. They do from 0 to plus 5 volts. So this will work. I'm going to take it out. I'm going to maybe go to the oscillator number 1. And I'm going to go all the way down on the knobs right here at the bottom. And what I want to do, I want to provide 0 volts completely 0. And remember, we are going to the 1, not to the 2. So I'm going to go down in the level of the oscillator number 2, and I'm going to keep the number 1 up. If I play the sequence, maybe I'm going to go to a square. We don't get a lot of change, right? And it's because we are not providing an instruction right here. As soon as I go up, it goes up in voltage, and this is going to change the pitch. As I keep going higher and higher, the pitch is going to be higher. That's the plan. All right, so that's how it works. Now remember that also we have the oscillator 2 CV, and it's going to be the same idea with that one. All right, so let me stop it. Now then remember, you have the oscillator 2 CV, and it works exactly the same. In this case, we are using the velocity knobs to provide an instruction or some voltage. You can use whatever you want right here. It can take from -5, it goes, down in pitch, or +5 in control voltage. Now it's time to talk about the VCA, VCF, and the VCO decay in, and we have them right here. VCF, the decay of the VCA, and then at the top we have the oscillator decay. Now on each part of the synthesizer, oscillator, VCF, and the amp, we have a decay that we can control. Now the main idea is that we can connect something right here, and we can control or modify how the decay works. And we're gonna be doing the same example than we did before. I'm gonna be going to the trigger out, and then go to the velocity, so we can use the knobs right here at the bottom. And I'm just trying to make everything super obvious. So again, since we are using this, you can see, where the knobs are, and you can hear and see what we are doing. Now the main idea again is velocity, and we go out to some of the decay, and in this case I'm going to be going to the VCA decay, and this one is the volume, right? I'm going to be maybe going down the volume, and I'm going to be playing the sequence. And if I go, maybe I'm going to go all the way down right here, all the way down on this attenuators. And if I play it back, we get something, right? So we get something. Still going to be going here. The main idea is that now we can modify how the decay works with whatever instruction that we provide right here. If I go up, it's going to go all the way up on the decay when we go right here. Just like this, we can create interesting rhythms. That's the plan. Now, if I disconnect it from the VCA, we can go to the VCF, which is going to be the decay of the filter. And I need to do some modulation for this, to work. It's still kind of doing its job. If I do no envelope, we get nothing. I'm going to go maybe do a little bit of decay, and I'm going to go down in the cutoff. And whatever it is that we do right here is going to be controlling that decay. If I go all the way down, we can hear the change. Same idea with the oscillator decay. And now this one is talking about whatever it is that we do when we use the envelope of the oscillator. If I play it and I do nothing, nothing is going to happen. I need to do something. And that is happening, especially when we go to the last 4. And if you change this control, it's still, it's going to modify the instruction. All right. All right, so this is what they do. Now the VCA, the VCO, and the VCF decay, they can take from -5 to +5 in control voltage. So you can use maybe an external source, something else from a different synthesizer, and you can go to that in and have the decay modulated. Okay, so moving on, we have the outs of the VCA EG, the VCF EG, and then the oscillator EG. And as we know, we have this 3 envelopes generators, and we can take whatever out, whatever instruction that they provide, and we can use it on something else. Just like we did with the VCOs in and everything else, maybe we can go out here and just control something else. And I'm going to be going to maybe the VCA EG. I'm going to take that envelope and just modulate something. Maybe I'm going to be going to the noise in. I'm going to be using the noise level. I'm going to connect that right here and just maybe move the cable. And if I play it back, you're going to be able, maybe if I go up on the VCF, to hear the noise. And if I go maybe all the way down in the level of the oscillators, that is that we are getting the noise. So the EG of the envelope of the amp is controlling the noise. If I disconnect it, we can hear that. All right. Now maybe we can take the out of the VCF EDGE and use whatever envelope that we use for the cutoff for the filter, and again use it on someplace else. Maybe I can go to the oscillator 1 and modulate the pitch of the oscillator 1. If I play it back, I'm using only the oscillator number 1 because it's the one that we are modulating. Remember that the EG is the one modulating the the pitch of the oscillator 1. So if I go down on the decay, we do pretty much nothing, or we do just a tiny little bit. And the envelope will just, make it modulate. If I disconnect it, we can clearly hear the difference. And as you guess, the same plan is going to, or the same idea is going to be with the VCO or the oscillator EG out. You can just use that envelope generator and go someplace else, maybe like the noise level. Since we know this one, I'm going to be patching it right here. And if I play it back and I go down on the oscillators, we are going to be getting just the noise. And the envelope, this envelope is just modifying it. Let me go here. We can make it wider or just shorter. All right, so with this, we just covered most of the ins and the outs. We have a couple more to go. And okay, so coming up next is going to be the external audio that you have right here. So you can import something, whatever other synth or other sound, or maybe an oscillator from a different synthesizer, and it's going to go through the path and go out of the edge, go out of from this synthesizer. So I'm going to be connecting this Roland, and I'm going to be playing a sequence. Right now, I'm just playing a sequence. So this is outputting some sound is going right here, but we cannot hear it on the synthesizer. Now, there are two things. First, this one needs to be playing, it needs to be doing something, because the envelopes are super close, so you're just not going to get it. Now then, when you connect something right here, it's going to disconnect the internal or integrated noise, and it's going to be using the EXT, external, like it says right there. So this is like the volume of whatever external source. Notice that, we are getting something. Now the sound is just super low, but right here, maybe it can go up on the volume of this one, and we are going to be getting both. Now, if I go to the cutoff, that is that if I chomp it, that is that we get nothing. So whatever we go or we connect externally is going to go through the path. All right. Okay, so now it's time to talk about the tempo. We have the tempo in right here. So this one, it needs, or it's going to accept -5 to +5 in control voltage. And this is the tempo knob. It's going to be this one pretty much. Now, if we connect something right here and we provide some kind of a voltage, it's going to mess with the tempo. And maybe we can use an example from here. We can use it with this synthesizer without using an external synth. I'm going to be connecting the tempo to the actual velocity that we have on the synthesizer. And now we know that when we do this, we can use the velocity to control the tempo. But also, I'm going to be disconnecting, these cables. Sometimes they just don't. Let me adjust the cables first. This is a mess. What we can do is the same trick that we've been doing. Going right here to the trigger. I'm going to go to the trigger. And then we can go to the velocity, so we can just disconnect it and use the knobs at the bottom. Now if I go all the way down and down in volume, I'm going to be playing it. Here's what happens. It's just messing with the tempo. Now remember that this is outputting voltage, and if you are outputting too much voltage, it's going to go super fast. Still, if I go all the way down in the knobs, it's going to be outputting no voltage, so it's going to respect whatever tempo that we have right here. Let me just make it a little bit darker. Right? So we are just doing whatever this does. But still, if we output some voltage, on this occasion, when it hits this point, it's going to go faster. Same thing if we go here, and just like just by doing this, when we hit this portion, this part, the tempo is going to change. Now, still, you can connect maybe some other synthesizer to here and just sync it up. That's a cool sound. Alright. Now still, the position of this knob, the tempo knob, still matters. Right? If you're going super fast and then you're changing it right here, it's going to alter it. Alright. Okay, so we just pretty much covered all the ins and all the outs. You have a couple more to go. You have the play and the stop. If you see it right here, play and stop. Now this one is going to take +5 and 0 type of voltage. It goes from 0 and 5. So if I plug something in right here and I provide some voltage, it's going to play or is going to stop the sequence. That's what that input is going to do. And last but not least, especially if you're using an external synthesizer, using it through the patch base, you have the advanced clock, which is pretty much the external clock. So whatever you connect right here is going to divide it and advance the sequencer following an external clock. So yeah, in conclusion, it will disregard this and use whatever it is that you plug it in right here. And you can, we can actually fake it. If as soon as I plug it, something right here, maybe a patch cable, is going to disregard the internal tempo. So it doesn't matter I'm playing and stopping. Right here is just disconnected, so it doesn't matter. Notice it goes a little bit crazy when I output some voltage. So again, this could go maybe to a different synthesizer and you're going to be able to control the tempo. Alright, so that's it. That's pretty much all the ins and all the outs. Hopefully you learned something new on this one. And remember, if you did, like and subscribe. And if you have the money and you want to buy me a coffee just to say thanks, you can go to the links at the description, or you have it right there in the screen. You can do PayPal, you can do YouTube thanks, or you can go to the Patreon and maybe be a 1-month patron and just, help the channel that way. Okay, so thanks for watching and see you on the next one.